What is a 3D point cloud? Tools, features, and applications of point cloud. What is a point cloud? A point cloud is the immediate digital output of the 3D scanning process. When you use a 3D scanner to capture the shape of a physical object, the resulting file format is a point cloud. In short, a point cloud is a collection of spatial data points, with each individual point representing a tiny spot on the surface of the scanned object, collected using one of the technologies described above. The point is expressed as a set of x, y, z coordinates. Because there are so many of these individual data points, the point cloud as a whole can be used to understand the 3D shape of the scanned object. However, not all point clouds are equal. More data points and a higher density point cloud means more detail, whereas a point cloud with just a few data points will only give an approximate representation of the real-world object. That being said, high-density point clouds require more computer memory and processing power. So how many individual points does a 3D point cloud contain? This varies by the size of the scanned object and the chosen resolution of the scan, but the number is typically in the millions. This makes the processing of point cloud data fairly CPU-intensive. Depending on the scanning technology, a data point in a point cloud may also contain RGB color and brightness information. Point cloud file formats. There are a few different file formats for point clouds, which can make the handling of the raw data confusing. However, most formats fall into two categories, and many are similar to one another and therefore easy to convert. Some formats are universal, while others are proprietary and have been developed by 3D scanning hardware manufacturers. ASCII. The first major type of point cloud format is ASCII, American Standard Code for Information Interchange, which conveys information using text. Each line of text within an ASCII point cloud represents x, y, z spatial coordinates. Common ASCII extensions XYZ, OBJ, ASC, PTX. Binary. The other major type of point cloud format is binary, which retains all information in binary code. Although binary data is harder to access and interpret, the files themselves are much smaller than ASCII files. Common binary extensions, LAS, PCD, FLS. A point cloud is a database of points that represent a digital 3D physical object or space in the 3D coordinate system. It consists of millions of individual measurement points with an x, y, and z coordinate. 3D point cloud is a highly accurate digital record of an object. Point clouds are utilized to generate 3D meshes and other models for 3D modeling. Various engineering and medical fields including medical imaging, 3D printing, manufacturing, architecture, 3D gaming, and virtual reality (VR) applications make extensive use of 3D point clouds. Based on the sensors used and the method to capture the cloud, each point can also include RGB color data or intensity information. These data reflect the return strength of the laser pulse that generated the point. Note that points in each 3D point cloud are always located on the external surfaces of the visible objects. Ray of light from the scanner is reflected from the object to create these spots. The denser the points in the point cloud, the more detailed is the object representation capturing even smaller details. The process by which these point cloud data are converted into a 3D model is known as point cloud processing. The time taken to create a point cloud depends on the number of required scans and the density of scanning. The normal mobile scanner takes much lesser time compared to advanced scanners. Generation of a point cloud. A point cloud is usually captured using any of the following two tools: laser scanners or photogrammetry. Laser scanners for 3D point cloud. A laser scanner includes various sensors and advanced technologies to gather hundreds of thousands of extremely accurate measurements per second. They also include an RGB camera to add color to the point cloud and an inertial measurement unit (IMU). A variety of types of laser scanners are produced to meet a specific range of applications. A terrestrial laser scanner (TLS) provides the absolute highest accuracy. Accordingly, they are used for specialized applications like measuring beam deflection, capturing a single object like a car or machine, or analyzing floor flatness with extremely high accuracy. Mobile laser scanners can also be used to capture point clouds with up to 4 mm accuracy. For normal building documentation projects, mapping active sites like factories, etc. where extreme accuracy is not desired, these mobile scanners will serve the purpose. Usually, laser scanners provide higher accuracy data than photogrammetry. Photogrammetry for 3D point cloud. Photogrammetry is basically a methodology to generate a point cloud. In this process, cameras are used to capture the space object from all angles and then process those images using specialized software to reconstruct the object space in 3D. Drones are widely used to capture point clouds. Features of the point cloud. The main technical characteristics of point clouds are: the point cloud obtained after scanning usually contains many unwanted elements like shadow areas, scaffolding, steam clouds, work machinery, etc. These must be cleaned to avoid difficulties. Point clouds in 3D only provide data concerning the position, measurements, and geometry of an object. However, they lack the rest of the object's information which the user needs to establish. The quality of the scanner is of utmost importance as the scan helps to locate, identify, and take references to objects in the obtained spherical photograph or bubble view. The 3D scanner tool is suitable for all existing work including overhauling, extensions, dismantling, etc. A point cloud is a fundamental part of an as-built. The point cloud system complements traditional paper documents and material lists. Point cloud systems generate the exact copy of something that already exists. The formats used for point cloud generation must be exportable and manageable in different design and visualization programs like E3D, Smart Plant 3D PDS, MicroStation, or AutoCAD. Turning a point cloud into a 3D model. Point clouds are a highly effective way of arranging information about the physical world, but they are not particularly useful for further activity once stored on a computer. Although it is possible to use point cloud datasets directly, many users will ultimately convert the point cloud into one of the following file types: CAD model, allowing the 3D scan data to be modified, reverse engineering, etc. NURBS surface model, turning the 3D scan data into a digital 3D object with curved surfaces, on-screen visualization, video game rendering, etc. Mesh, turning the 3D scan data into a polygon or triangle mesh, 3D printing, etc. The process of turning a point cloud into a 3D model is known as surface reconstruction. This is because a point cloud itself does not contain surfaces, only a multitude of discrete coordinates. Of course, the conversion of point cloud data into 3D models is not a simple process. Point cloud processing software must use algorithms to figure out how to represent a collection of points as lines or shapes while determining which data points are genuine and which are outliers. The best software uses deep learning to contextualize point clouds and understand what the data is supposed to represent. Point cloud processing software. Users may need various types of software to create a smooth 3D scanning workflow. However, one of the most important tools is point cloud processing software. This software is used to manually edit point clouds, to remove outlying data points, for example, and render them visually. Different algorithms can be deployed to automatically filter outlying data points. Functions of point cloud processing software may include manual editing of the point cloud, automatic cleanup and filtering, offloading tasks to the cloud, rendering, point distance calculation, registration, conversion to mesh, conversation to NURBS. Popular point cloud processing software includes Cloud Compare, free and open source, Point Cloud Library, free and open source, Leica Cyclone, Faro Scene, Autodesk Recap, and Trimble RealWorks. Applications of point cloud. As point cloud provides an accurate, comprehensive, and precise digital picture of a real object, it provides huge value in a wide spectrum of applications. Some of the most common applications are construction progress tracking. By regularly capturing the point cloud data, the construction progress of any plant can easily be measured. Building information modeling, BIM. By processing the point cloud data in a specialized BIM modeling software, accurate and comprehensive models can be generated. Floor planning, point cloud can easily be used to generate a floor plan for any structure. Operational 3D model creation, point clouds are extensively used to generate an operational 3D model of any asset. As built, point cloud software eliminates costly and time-consuming site visits and allows the designer-architect to visualize and convey new concepts. Point cloud has become popular for all design industries as it gives an instant virtual model to test ideas with. Inspection and measurement, point clouds are also used to create 3D CAD models for manufactured parts, for metrology and quality inspection, and for a multitude of visualization, rendering, animation, and mass customization applications, check deformations over time, etc.